Hello everybody, Don here. In this episode of The Naturalist, we're visiting Wright State's woods to talk all about fall colors. So let's take a hike. All right, here we are in campus of Wright State University at the Wright State's woods. We're going to talk about fall colors because the woods are on fire right now. This is a good place to talk about this kind of thing because Wright State's woods is filled with the kinds of trees that give us the best colors in the fall. And that are maples, primarily sugar maples, and some red maples. So most of what you're seeing on fire in front of me, save for the few green holdouts, are maples. So let's go take a look at a couple of these. We might grab a few leaves and then retreat down a trail a little bit to talk about it. But this tree right away, with these crimson red leaves, is a red maple. So we're going to take one of those, talk about those, and go down here in the edge of our woods where the formal trails begin and grab some sugar maple leaves. Compare and contrast those trees. Okay, so I have in front of us two leaves, and both really bright red, reddish orange. One on the right, as you can see, has primarily 3 lobes. One on the left has 5 lobes. And that makes this one red maple and this one sugar maple. Okay, and these are the stars of the fall colors in Wright State's woods and in many woods. This particular trail, I'm just sort of below the library at Wright State University. So this is right next to the parking area. These woods are just awash with color right now. I hope you can see that. Okay, as I'm peering upward into the canopy. All of these trees with the yellow, orangish leaves are sugar maples primarily. And then again, we have a few red maples scattered here and there. All right. So exactly, you know, things are starting to fall too. So we, I think, are at our peak color right now, but things are starting to fall. Okay. So we have a mixture of things on the ground here. There are some classic comparisons we can make here. Okay, here's an example of 2 species that are very closely related and in fact may hybridize. The one on the left is sugar maple, okay, which we just identified. The one on the right is called black maple, okay? You notice that black maple still kind of has that 5-lobed appearance, but the bottom lobes are minimal, and the lobes are not very deep, okay? So this shape that you see in my right is more characteristic of black maple than sugar maple, all right? Just kind of more blunt as well. Okay, black maple is, again, thought to be a close relative. Some people have thought it was even a subspecies of sugar maple, but in any case, they are distinct. You can tell them apart quite a bit by their leaves. You can see the difference in coloration too. Black maple tends to turn yellow in the fall before it drops, primarily yellow, where sugar maple is yellow and orange, red even, okay, before it falls. Nonetheless, we just have a fantastic display of these things on the ground and up in the air here in our woods right now. So let me tell you a little bit more about Wright State's woods in general. Wright State's woods is about 225 acres, and about 100 of those acres are considered old growth forest. You all know I'm a fan of old growth forest, and we have it here right on our campus. The other 100 acres or so had been farmed in the past and had been let go from that, anywhere from, say, 60 to 100 years ago. So what we have in our woods is a patchwork of different aged forests, okay, from old growth forests to some forests that might only be around 50 years old, 50 or 60 years old. And that makes Wright States woods very useful for teaching and research, to compare and contrast those kinds of, past land use histories. So these woods are used extensively for research. I'd say focusing in the Department of Biological Sciences, but other departments use it as well. Our Department of Chemistry has done work in here. The art department even does work in here. Okay, so there's a lot of research that goes on. And of course, teaching. Teaching brings students into the woods here to observe birds, to observe plants, just learn about nature in general. And so Wright State is quite unique in having such an intact forest right next to campus in a largely suburban setting. Okay, to have this right next to your campus while being in the suburbs is pretty much unheard of. So Wright State is dominated, the woods are dominated by, like I was saying, sugar maples are very abundant, oaks of several species, hickories, tulip trees, beeches in certain areas. So now, again, this is not a nature preserve, or excuse me, a park in the sense that, a clean understory is maintained. There are trails scattered throughout the park, throughout the preserve, that are, pretty easily accessible. I'm walking on one that's used as somewhat as an access road for small vehicles by the grounds department, but it's also a walking trail. But there are also smaller trails that will go off more into the forest itself. And you can find a mix of that traversing the woods throughout both the old growth and the younger growth sections. So we're in one of the sections that is considered old growth. You can see the large trees in front of me. Here's a large hickory, for example. Okay, this is either a pignut or a bitternut hickory. We have bitternut hickories in this woods. And behind it's a large white oak. Okay, so most of the old growth forests I visited are going to have these species in Ohio. Okay, white oak is a sentinel of the old growth forest. All right, so that tree is probably about 250 years old or so. Okay, which surprises some people about how old these trees can be. Now, I'll show you how we know that, okay? And it happens to come from evidence like this, all right? So here's a downed tree. This was died for some reason. Of course, that's a natural process in woods. Okay, this was a white oak. You can see it's been cut up, okay, into pieces, cleared from the trail. And, you know how you can age a tree. When it's cut, you just basically take a look at the trunk and count the rings from the center out to the outer edge. Okay, now I'm not going to do this in front of you, but I did this the other day. Okay, so this tree, this white oak log that we're looking at, is about 2 feet in diameter, maybe 2.5 at best, but closer to 2 feet in diameter. I counted 175 annual rings in that trunk the other day. Okay, so that's a 2-foot diameter tree, 175 years old. And when you come to this white oak nearby, this oak near the base is closer to 3 feet in diameter. Okay, so what you get from my counting over there is that you have about 80 to 100 years per foot in diameter for a white oak. And again, in past episodes, I've mentioned how white oaks grow pretty slowly. So if you see a large white oak, you know it's old. So this tree in front of me is about 3 feet in diameter. It's probably about 250 years old. Okay? And of course, these are the kinds of things you you look to see in old growth forests. And we have a lot of them in these woods. Not only white oaks, lots of other species. Let's take a look at a couple other things in this section of the forest. Large trees or otherwise. And here's a beautiful large black walnut I'm approaching right now. Okay, black walnut, if you look up at the canopy, has compound leaves, okay? One big leaf with multiple leaflets. But one thing about its bark, it has a dark, almost a purplish tinged bark that is very blocky, okay? It has very large channels and blocks to it, all right? Very blocky bark, and that's one way to identify black walnut by its bark. Of course, sometimes you need to do that, and especially you need to do that in the winter when there's no leaves, but partly because the leaves are way up there. They can be hard to see. But in any case, that's a nice big black walnut. Many board feet in that tree, which I've said in past episodes is a very economically valuable tree. All right, so throughout this section, I'll just point out to you that we have about 15 acres of this forest are under a conservation easement. Okay, here's one of the corners of that easement. In fact, we have to clear this dead log. But basically what an easement is an agreement between the landowner and usually a land trust or an agency that manages the easement that says that, you know, that the land will be preserved under certain conditions or pertaining to certain conditions. And it's agreement to keep, you know, forests like this intact for as long as possible without development or destruction in any way, or construction, okay? When you're in a suburban area, there's always threats to development of tracts of land like this. Okay, here's a monster sugar maple. Let's take a look at the canopy view. Okay, these trees are approaching 100 feet tall easily, if not more, 120 perhaps. This is a mighty sugar maple. Again, this is the tree we get maple syrup from, primarily. All right, and that kind of reveals the kind of bark that sugar maple has. It has a real variable bark, but it often has these large plates that stick out from it that are stiff. Okay, they're tough to break off. So that's one way that sugar maple can look. But there is a lot of variability in that. Sugar maples and white oaks and, you know, many species have really variable barks. I'm just going to give you an example of that in a second. So here's a large sugar maple with the large plates. I'll walk right over here. And show you this sugar maple. This is a sugar maple as well. Okay, and it is practically smooth with very small, you know, crevices in its bark. So now that's a much younger tree than what we're seeing over there, but that just gives you an illustration of how variable their barks can be. That's a really interesting trait, how variable they can be. All right, now I'm gonna take us to see one of the sad things that happens once in a while, which again is natural. But this was one of our largest trees on campus. Okay, this was a northern red oak. All right, you can see that it's on the ground now. Okay, it's been uprooted and blown down, essentially. Now, we aged this tree about 3 years ago. And we had to do some estimating on it, but we aged this tree at about 125 years old. And it was nearly 5 feet in diameter, okay? So that makes red oak much different in growth rate than the white oak I just described to you. Okay, so this is a 5 foot diameter red oak, only about 125 years old. or 135, I think it might have been, where that 3-foot white oak over there, we estimate to be about 250 years old. All right, so that just shows you that northern red oaks just grow much faster than white oaks do. That's a point I've made in past episodes. Okay, now when this tree was standing, this just happened this past summer, okay, the summer of 2023. When this tree was standing, it looked pretty healthy. You couldn't see any obvious openings into its center or anything like that. But now that it's fallen, you can see that this tree was hollow inside, okay? The whole middle of that tree is gone, and it had been gone for a long time. Now, a lot of these large trees can be hollow and stand for a long time. The center of that trunk is really non-functional in terms of the physiological functioning of a tree. It's dead wood, essentially. It does serve some structural role, but it's not necessary for the survival of the tree. It's these outer parts, okay, where all the action happens in terms of the outer parts, you know, within an inch or two of the bark itself, where the movement of water, the movement of sugars between the roots and the shoots mostly occurs. All right, so a tree can stand for a long time, even though it's hollow, as long as it has a functioning outer layer of several inches in thickness. Okay, and proof of that is you've probably seen pictures of maybe great, you know, redwoods or sequoias out west in California that have a tunnel carved through them. And the tree's perfectly healthy. Well, for the most part, as long as it has living bark and sapwood in parts of the trunk, you can take the center out like that and it won't kill the tree. To kill the tree, though, it's simple. You don't have to cut a tree down to kill it. All you have to do is girdle it. And that's just basically making cuts, or a single cut of about 2 inches deep, 2 to 3 inches deep around the circumference of the trunk, and you will kill the tree. Okay? And of course, we've talked about how emerald ash borer kills ash trees by girdling their trunks. And that's because they eat that precious vascular layer where, you know, basically all the transport happens in the tree. And right on cue, I had in past episodes talked about blue ashes as surviving in the face of emerald ash borer. And here's just another example of one. Okay, this is a pretty nice sized blue ash tree, and it's still alive. It has a green canopy up there right now. It was suppressed quite a bit when this big red oak was here. Now that that red oak is gone, this thing should probably fill back out again, as well as the other trees around it, okay? When a big tree falls like that, it creates what's called a canopy gap. I know I'm kind of looking into the sun right now, but this tree formerly dominated this area. Its canopy shaded all the trees below it, and this was the tallest tree in the neighborhood. Once it falls, it creates a gap in the canopy. If you look up now, there's a kind of an opening in the canopy now that lets in more light. And so the things that are here will take advantage of that. Either the trees or the shrubs, the understory plants on the forest floor will all take advantage of that. I expect to see that happening over the next few years. That this will all grow up now pretty rapidly with, you know, rapidly growing trees and shrubs that are trying to take advantage of that, or are taking advantage of that increase in light, okay, and the relaxation of light competition. Okay, I can hear acorns falling in the background and hickory nuts. Okay, here's a nice patch where there's no invasive shrubs. We do have an issue with that here, just like most of forests in Ohio. We have a lot of amber honeysuckle, but here's a nice area that doesn't have much. It has some spice bushes we've talked about before. I see pawpaws in the distance, which we've also talked about before. Now, in these suburban settings, I'm going to devote an episode to this in the future, but in these suburban settings, sometimes you can have real problems with deer overabundance. they become kind of very tame. There's no hunting allowed in this preserve, so there's a resident deer herd that's, more abundant than it should be. And so they tend to feed heavily on their preferred foods in the understory, and that leaves, only the things that they don't prefer to really flourish. Okay, and those include things like pawpaw. Again, we talked about how pawpaw is not really eaten by deer much in the past. These large-leaved trees you see in front of me, young pawpaws. And then spice bushes. Okay, the shrubs here with the yellow leaves, they also don't seem to get eaten a great deal by deer, at least not enough to kill them. So, but nonetheless, there are not many honeysuckles in this particular patch. Deer kind of do eat some honeysuckle, but honeysuckle also doesn't do as well in the shade as it does in areas with more light. So as I look out toward the edge of our woods here, where there's more light, honeysuckle is lining the woods, okay, where it's not found in here very much. And that's one place that's reserved for our native shade-tolerant species where honeysuckle can't outcompete them. All right, so let's just continue walking and see what we see. So here's an example. Here's a sign. Okay, this is an example of a really large ash tree that used to be here. This unfortunately was killed by emerald ash borer. This was almost certainly a large white ash. It's been dead for several years now. And it was a big one. Okay, and this just illustrates, what that beetle, the damage that beetle has wrought. Okay, that was a large tree. And wow, it's a towering tree, and it's still standing upright, but it'll fall soon. It'll be on the ground soon. I'm going to get out of the way in case it does. Wright States Woods also is filled with chunks of granite that I talked about in a recent episode. So I'm referring a lot to other episodes here, but here's a big chunk of granite. This is a big one that was brought here by glacial activity and left behind. Okay, this rock would have come from much farther north locations, what is now Canada, for example, carried by the glaciers and then left behind when they melted and retreated. So Wright States Woods is filled with these, what we call glacial erratics, that kind of don't belong here, but they're really cool to see when they are here. Now the bedrock in this area is limestone. So the actual rock in the ground is limestone, and that gives our soils here a pH that's kind of in around 6.5, 6.8, pushing toward neutral. If you go to, say, eastern Ohio, where there's sandstone bedrock in the areas that were not glaciated, you're going to have soils that are more in the order of 5.5, much more acidic. Okay, and that will lead to different plant communities. That affects soil nutrient availabilities and things like that. And that influences what can grow here. So I will be doing subsequent episodes in places like, southeastern Ohio, and we'll compare and contrast some of the vegetation that you see there and other wildlife for that matter with what we see here in southwestern Ohio. Okay, here's something that is flourishing right now all throughout the woods. Talked about this at Stages Pond. These are turkey tail mushrooms. Okay, these are thin, leathery bracket fungi. Okay, they feed on dead wood, and these are actually edible. Okay, there's been a fair amount of medical research on them, and either grinding that up and making a tea or something out of it has various medicinal benefits that are actually seem to be legitimate. It pays to be a little skeptical of all the claims you see about medicinal plants and things like that, because many of these things aren't really well tested scientifically. And so it just pays to be skeptical, but that's one that has had a fair amount of research done on it. Okay, I'm here late in the day, and I'm going to head toward parts of the woods that still have good light for filming. All right, so I'm going to head back this way. But all around me, I'm seeing, large sugar maples, white oaks, again, some red oaks. A lot of the smaller trees now are mostly maples. Oak regeneration is a problem in most of the eastern US, for that matter. Okay, these oaks make abundant acorns. They try to reproduce, but you don't see many small oak seedlings or saplings in these kind of woods. There's been tons of research trying to figure out why that is. There's various hypotheses that have been raised. One is that thing I just talked about, the overabundance of deer, okay, deer browsing. That certainly contributes, okay. Oaks are a preferred food of deer. If they can get near them, they'll eat them. But there are also some hypotheses about things like lack of fire. Okay, there would have been periodic fires that went through woodlands, especially through prairies. And and what fire does is it suppresses certain species that can't handle the fire or recover from the fire very well. And it favors species that can handle that fire and grow back fairly quickly, all right? And oaks are like that, okay? They're much more fire tolerant than, say, maples are, all right? So when fires are suppressed, not allowed to run, you don't have that kind of natural management anymore, okay? So restoration of fire regimes into woods like this can be important. I see our suburban deer right in front of me. We'll see how close we can get. They're usually fairly tame. I see 4 or 5 deer, probably feeding on acorns. See how close I can get. They're quite tame in these woods, although these ones are a little bit more skittish. Deer are interesting. Deer tend to be very sensitive to smell, but not as sensitive to sight. Okay, if they see you without smelling you, they don't get hyper concerned, but as soon as they smell you, they tend to take off, especially if you're talking about wild deer in, more wild habitats. These deer are more suburbanized. They are a little bit nervous. I hope you can see them going. There's 3, 4. Okay, those look like all female deer. Okay, I don't see any antlers or starting antlers. But suffice it to say, if I was in, say, southeastern Ohio in the bigger woods with wild deer, less accustomed to being around humans, those deer would be long gone. They would be half a mile away or quarter mile away by now. But I still see them over there just milling around. They're just waiting to see what I'm going to do. All right, so what I'm going to do is just keep taking a walk. If they want to join us, that's great. Okay, there's a lot of pawpaws in our woods, partly because they are tolerant of deer. But back to oaks again, there's more hypotheses about oak regeneration regarding climate change. Okay, the idea that moisture conditions are changing, that currently the current conditions just don't favor oak regeneration relative to other species. All right, now, so it's unlikely to be one cause, but there's a lot of research in that just simply because of how important oaks are. One example is that oaks can basically serve as hosts for like 400 species of butterflies, okay, caterpillars and butterflies and moths. They produce acorns that are a tremendous food source for many species. I was also seeing squirrels and chipmunks running as I just walked through here, which feed on acorns, among other things. Okay, so oaks are just a tremendously valuable resource. They're keystone in forests. Okay, as I walk through here, you will notice that a lot of these trees are tagged. Okay, so I'm going to give a shout out to a former faculty member at Wright State, faculty emeritus, named Jim Runkle. And he has this forest, as well as several others, as part of long-term monitoring of forest dynamics. So he will, he's marked many trees throughout our woods and several other woodlots elsewhere, and will periodically revisit each tree in the inventory to update, on its status. How much has it grown? Is it still alive? Basically the demographics, to look at long-term changes in forest structure. Okay, and it's, he's had this kind of study running for decades now. And so even though he's retired, he still revisits these sites like this and other places to keep track of how these trees are doing. And so that's tremendously valuable research. And it can be tied right into changes in land use history, climate, deer abundance. There was a time when there wouldn't have been deer in these woods. 40, 50 years ago, there were probably far fewer deer in these woods than there are right now. So you can link changes in trees and their status to other changes going on in the world. Okay, I'm going to kind of pick it up a little bit, try to hit some highlights because I'm losing light. I might be in here long enough to see bats, which is a segue to the fact that we have several bat species in these woods that utilize these woods, including a federally endangered bat called the Indiana bat. All right, and so this is a brown bat, and it's been radio collared and tracked to our woods in the past. And then auditory surveys have also indicated that it's in our woods. Okay, so these woods house a federally endangered species, which also makes these woods important. Okay, we've come down from sort of an upland up toward the edge of campus. You see where the light's still coming through, down to a bottomland. There's a small stream nearby. It does have fish in it and so forth. We'll just hit a couple of highlights down here. I know there's a few trees here, tree species that I have not pointed out to you in the past. So let's go see those. There's, again, red oaks, white oaks, sugar maples. You will notice too, if we look around, the trees that are still green tend to be oaks, okay? Because they are the last to change for the fall in terms of large tree species. And some of them actually hold their leaves till very deep into the winter, especially the white oaks. You will notice too, a lot of the green shrubs you see in front of me are honeysuckle, amber honeysuckle. And they hold their leaves for a long time in the green state. And it's thought that that could be one of the reasons they're so invasive. They have a very long, productive leafing season. So they photosynthesize longer than our native shrubs. That might give them some kind of competitive advantage. So what is color change anyhow? Well, circling back to the start, in front of me you see a real range of colors from greens to yellows to oranges. Most of that change is due to the loss of the green color. Okay, the green color is given to leaves by chlorophyll. And if you remember, leaf color represents the wavelengths of light that are being reflected by the leaves back to your eyes. And so when plants are green, they're filled with chlorophyll, which reflects green light, and you've got the trees appearing to be green. I got a visitor coming up here, so I'll pause for a little bit. Hello. Okay, returning to my point. So those shrubs in front of me appear green because they have an abundance of chlorophyll that's still healthy in them, reflecting green light back to my eyes. I look at the other yellow and orange ones, and that green color is gone because the tree has metabolized the chlorophyll to recover the nutrients present in it, like nitrogen and magnesium. And what that does is then reveal pigments that have been in those leaves all season long. And the abundance of those pigments we're seeing are carotenoids, the kinds of pigments that give the colors to, say, carrots, where their name came from. Carrots and tomatoes, oranges. So those carotenoids, those colors, those yellow and orange colors, they've been in those leaves the whole year. And they just get revealed in the fall as the chlorophyll gets metabolized. All right, and then, but the plant doesn't tend to recoup nutrients out of carotenoids. Most of those kind of leaves drop with the carotenoids still in them. Okay. Now there are some pigments that are produced in the fall, which is a little bit different. Okay, they're actually, they accumulate in the fall, and those include anthocyanins. I'll try to, before we're done today, I'll try to find a plant that has an abundance of anthocyanins, but these tend to give you the deep red colors. And so flowering dogwood is an example of a tree filled with anthocyanins. Okay, here's a tree I wanted to point out. Okay, this is an American sycamore, this leaning tree right above me. And sycamores can grow to be very large trees. And they're associated with riparian areas, stream sides, rivers, wetlands. They like wet soils, okay? And they get very large. They were not harvested like oaks and other species, maples for timber and lumber. The only thing that sycamore wood is known for is to make butcher blocks that I can find, all right? So that was their primary use. So you're left with a lot of giant sycamores around places like Ohio. Some of the largest trees in Ohio are sycamores. Okay, and they're very characteristic. You see the upper branches, they're very white, very smooth, white bark. Okay, and the younger parts. The older parts are brown and flaky, as you see in front of me. All right, and then they make a leaf that has maple-like leaf qualities. And here's a dead and brown one. Okay, but that's an American sycamore leaf. All right. All right, moving along. There's been a lot of tree death and tree fall in these woods in the last, I'd say, 2 decades since I've been around here. Again, that's partly natural, but we've had an abundance of windstorms. Here's a dead oak tree that'll be falling probably sometime soon, or half-dead tree. But here's one this one also just happened in the past year. Okay, this tree that I'm approaching was a bitternut hickory. It was a pretty big one. There's some trail markers, signs on it. Okay, it was a bitternut hickory. And it basically got blown over. All right, you can see how it basically peeled off. Most of it's laying out here, okay? Now hickory wood is known for being used in things like axe handles, okay? The handles of sledgehammers, things like that. Okay, if you see this in front of me, you can see that the wood is very tough and flexible. Okay, it flexes quite a bit. You can see that. All right, so that makes it very useful in an instrument, a tool where you don't want it to snap. You don't want it to break every time it bangs into something, right? So this is a good example of why you use hickory in things like axe handles, because it's a little bit flexible. When you pound that sledgehammer or that splitting maul into a block of wood, there's a little bit of give in the handle, and if there wasn't, it's likely your handle will snap, all right? But nonetheless, a student and I were out here, we realized that the reason this broke like this is up where at the top of this broken tree, which you can see in the rest of the trunk that's laying down, there was a hollow spot, okay, that had started to rot. And it weakened the tree at the top, you know, halfway up the trunk like that. Okay, so from the ground, this tree looked completely healthy, but there was a weak spot up there, and with the right wind, it blew it over. All right, so we lost a nice bitternut hickory. I'll have to point out bitternut hickory to you elsewhere where there's still some intact leaves and the nuts. So, okay, keep moving along. There are miles of trails through Wright State's woods. I'm just taking us through a very short piece. Going to kind of hit one more main highlight up here. Okay, there goes some birds. Couldn't identify them. Our woods have a really nice wildflower display in the spring as well. Get back up out of the bottomlands, so we're starting to walk up to the upland. I'm here late in the day. I'm at the golden hour, basically. There's a nice white oak. All right, so let's just cross here. I love this time of day to be in the woods looking out the border like that. Just looks like it's on fire out there. Just beautiful. So Wright State's woods is publicly accessible. There are places to park around its border. You could actually park on campus in visitor spaces, and it's an easy walk over to the edge and find the trails. Quickly, here's a little facility that we have here in the woods that is utilized in teaching. And don't know that much is happening right now. This is a bird blind. Okay, a bird blind is basically a little structure that you hide in order to watch birds, okay, without them really being bothered by you. And you can either just hide in there and sit and wait, or seeds and bait can be put out in front of it, and that, you know, basically lures things into you. So let's take a look at that. Okay, so there are a variety of types of feeders out here. Suet feeders, seed feeders, and so forth. They're not filled right now, but you know, this kind of site is utilized in teaching, for example, to examine bird behavior, to see what birds prefer to eat, where they prefer to forage. Is it on the ground or is it in the trees? What types of food do they prefer? What species you can see, and a whole variety of things that you can do with it. Okay, so that's Wright State's bird blind. A good time to come to to that is in the winter, when birds are really heavily visiting those feeders. So that's just a little, and it's a short trail, an accessible trail to the edge of the woods in campus proper. I've waited for the right day to do this, so I'm here a little bit later in the day than I'd prefer, but it's a nice one. It's a nice fall day, right at our peak. Lots of glacial erratics around here. I've seen other people enjoying the woods while I'm here. See northern red oaks. Here's a really nice northern red oak over here. Take a look at that. Yeah, this is a big one. Yeah, this is nearing the size of the one that fell over that I showed you earlier. Not quite as large. That's a nice one. Looks to be in good health. Again, it's not always clear what's happening in the middle of that tree, but from you know, everything I can see, looks to be in great health. Again, red oak is named that because of the reddish coloration of its wood. So when you get really good with trees and wood, you can just basically take a look at the wood itself without any bark, just the wood, the grain, the color, the weight, the density of it, and tell what kind of wood it is. I'm pretty close to being there, but not completely. Just skirt along the top here. There used to be a lot of ashes, as I pointed out. A lot of these logs you're seeing on the ground were ashes. They're now basically mature white and green ash, which used to be abundant throughout these woods, is basically non-existent as a large tree anymore. There are small seedlings and saplings of ashes still, okay, that they're the orphan children, if you will, of those trees that don't exist anymore. And they will grow. They'll grow back, and they'll grow for a while until emerald ash borer finds them again when they get large enough to be attacked. That's the unfortunate part of that story. Yeah, here's another corner on our conservation easement. We would very much like to have more acreage under easement, but this is what we have for the moment, okay? And we're continuing to work on that sort of thing. I can tell I have some visitors near. I'm getting near to the edge of our woods. So I think I will conclude our walk with just a look at this hickory, which looks like a bitternut hickory that I just showed you down below. But this one's alive. That's the difference. Okay, this nice lacy, tight bark is characteristic of bitternut hickory. All right, so I'll leave you with that. So thanks for joining me on my relatively quick walk through Wright State's woods at the peak of fall colors. And just remember, happy fall, y'all. See you later.